Hello everyone, welcome to my channel. I am Prabhureddy. I am from Department of Basic Science, Sri Venkateswara College of Engineering, Bengaluru. Subject Applied Chemistry. Subject code is BCHEE102. And the course is ECE. The topic we will be covering today is corrosion chemistry. The topics that will be covered today are introduction to corrosion, types of corrosion. Under the types of corrosion, we will be discussing differential metal corrosion and differential aeration corrosion. And then we will move on to corrosion control methods. Under corrosion control methods, we will be discussing about classification of corrosion control methods. Now we will start with the topic corrosion. Let's first see its definition. Corrosion can be defined as the destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. For example, rusting of iron. As you can see in the top picture that there are brown depositions on the iron. That is an example for rusting, and another examples can be given as green scales that are formed on copper vessels when they are kept open. You can see that in the second picture below. Corrosion may occur either in dry environment or in aqueous medium. The corrosion which occurs in dry environment is called dry corrosion, and the one which occurs in aqueous medium is called wet corrosion. First, let's see about dry corrosion. Dry corrosion is also called as chemical corrosion. Dry corrosion involves the direct attack of metals by dry gases mainly through chemical reactions. It occurs by direct attack of atmospheric gases such as oxygen, hydrogen, sulfide, halogen, and sulfur dioxide on the metal forming oxide layers. Like for example, the attack of dry air or oxygen on a metal to form an oxide layer over the surface. Now we will see wet corrosion. Wet corrosion is also called as electrochemical corrosion. Wet corrosion involves reactions in aqueous solution medium. Conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. For example, rusting of iron. Now let's see the types of corrosion. The first type of corrosion is differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each another and exposed to a corrosive conducting medium. The metal with lower electrode potential acts as anode and undergoes oxidation and gets corroded, and the metal with higher electrode potential acts as cathode. For example, tin coating copper vessel, bolt and nut made up of different metals. The rate of corrosion in differential metal corrosion depends mainly on the difference in potential between the two metals. Higher the difference, faster is the rate of corrosion. At anode, the metal oxidizes and becomes into ions, but at the cathode, the reaction takes place depending upon the nature of environment. If the nature is acidic, hydrogen ions form hydrogen molecules, and if the nature is alkaline or neutral, the water molecules react with oxygen and gives hydroxide ions. Another type of corrosion is differential aeration corrosion. Differential corrosion occurs when a metal is exposed to a different concentrations of air or oxygen. Part of the metal exposed to a lower concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of the metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. This kind of corrosion is called as differential aeration corrosion. For example, in the diagram shown, the iron rod is partially immersed in sodium chloride solution. Part of the metal immersed in solution is exposed to lower concentration of oxygen, which becomes anodic and undergoes corrosion. But the part which lies outside of sodium chloride solution is exposed to more oxygen and becomes cathodic and remains unaffected. You can see the reactions mentioned. Differential aeration corrosion is classified into two types. First one is waterline corrosion and the second one is pitting corrosion. First, let's see waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time and the inner portion of the tank below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. The distinct brown line formed just below the waterline due to deposition of rust. At anode, the metal oxidizes and forms ions. At the cathode, water forms hydroxide ions by reacting with the oxygen. Here is an example for differential aeration corrosion. Ships which remain partially immersed in seawater for a long time undergo waterline corrosion. Here is the you can observe the waterline under which the corrosion is occurring. Above the waterline, there is no corrosion or it is less corrosion, but under the water, it is more corroded. Now let's see about the another type of differential aeration corrosion, which is the pitting corrosion. Pitting corrosion is a type of corrosion which is observed when dust particles or oil drops are deposited over the metal surface. Pitting corrosion occurs when the metal surface is not homogeneous or when the external environment is not homogeneous. Crystallography directions are not equal in reactivity and it also occurs when the environments are not uniform with respect to the concentration. Let's see how pitting corrosion occurs with the help of a diagram. Pitting corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergoes corrosion and forms a pit. The remaining area of metal which is exposed to higher concentration of oxygen becomes more cathodic and remains unaffected. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area corrode faster because accepting electrons from the cathodic area increases. Here you can see a diagram where iron metal is there. In the iron metal, there is a pit created due to the deposition of dust particles which acts as anode, and the areas adjacent to the pit are cathode. At the anode, iron oxidizes to form iron ions, and at the cathode, water forms hydroxide ions. Thank you everyone for watching this video. I hope this video was helpful for you. If you found the video interesting, please like, share and subscribe.